Okay, good. So let's get started. Good afternoon, everyone. I would like to welcome you to our workshop. Our project is called RIMORPHIS, which stands for River Information Morphology System. So this is our second workshop, and the goal of this workshop or objective is to just give you an update on what we have been doing and to get your feedback. So the way we are going to do this is in the first hour, we will do most of the talking. We will show you what we have. And in the second hour, we would like to hear from you. This is our agenda for today. So my name is Venkatesh Merwade. I'm a faculty in the Life School of Civil Engineering at Purdue, and I'm the lead PI on this project. So I'll start off with a brief overview of our project. And after that, the Iowa team led by Ibrahim Demir and Marian Masti, they will talk about the cyber infrastructure. Then I'll again talk about the tools we are doing. We will have question and answers. Then we are going to have a 5-minute break. And then, as I said, in the second hour, we are going to do a lot of listening from you. So we'll have a breakout session and discussion. If you have any questions or comments, please type them in the chat box. We are also going to give you a link in the chat box for Google Doc where you can type questions, put comments. Since this is virtual, we will not have a chance to talk to you in person. So whatever you want to say, please do that either in the chat box or there will be a link in the chat box for a Google document. So please feel free to type anything, and also please be respectful with the comments. And we will try to respond to all your questions as we go along. If you are not able to get to your questions, we will do so after the workshop. So it will help us if you provide your name and email if you want answer to a specific question, or if you don't get answer to your question. If not, we are going to compile all the questions and also include all the answers and share that document with you after the workshop. So as I said, I'm Venkatesh Merwade. I'm the lead PI, and the co-PIs that we have here are Amanda Cox from St. Louis University, Ibrahim Demir from University of Iowa, Toby Minier from University of Colorado, and Marian Masti from University of Iowa. So here is our problem statement, and I assume or hope that all of you are aware of some of these issues that we have with our river morphology data. So river morphology data is not easily available. Even when it is collected, you cannot really find it. So there is a lack of access for river morphology data. And wherever these data are collected, they are collected for very short reach, which means if you are interested in doing a study at the watershed scale, you cannot get river morphology data for a large reach or for a river network. So even when we have river morphology data, it's not available over large areas. And many times these data are collected in a form that we cannot really use. So for example, many times when we do bathymetry surveys, they are collected as a series of points. And let's say if you are interested in some modeling, hydraulic modeling, in this case, you are interested in getting cross sections, or if you're doing a 2D modeling, you want a mesh. So in order to convert those points into cross sections or mesh, you need tools which are again not very easily available. So to address that problem, we proposed this solution, and we call this system as RIMORPHIS. As I said, it stands for River Morphology Information System. So our goal was to create a user-friendly, scalable data and information system for river morphology research. And we wanted it to be equipped with tools that you can use to discover data, download the data, analyze it, integrate with other data sets, and create new knowledge. We wanted to make sure that the system that we are going to develop or developing, it can connect with other resources where you can find data that are collected by the community. And finally, we wanted the system to be a platform for visualizing the data and also collaborating to enable transparency and reproducible research outcomes. So we had this vision or a vision for a solution, and we proposed that to NSF, and NSF was kind or generous enough to support our project. And what you see on the screen is the official name of our project. When we first submitted our proposal, we called it RIMORPHIS, and then we learned that there is already a tool that is called RIMORPHIS, so we changed it to RIMORPHIS. And what you see here are the award number. So you can see we started in 2020, so we are in 2022, which means we are in the second year of our project, and officially the project will end next year, but we are going to continue. So we got funded from the NSF Geoinformatics program. So what you see on the slide are 3 different tracks: catalytic track, facility track, sustainability track, and you can read the text associated with what each track means. So many times when we talk about our project and present to people, it is exciting and we are excited to work on this, but as you will see, that this is a prototype project. So what we are doing is we are going to show what we are doing and what can be done, but in order to be scalable and used by the wider community, we have to continue working on this. So what you are going to see is a prototype, which will be useful, but again, it will need more work as we go along. So we are in the catalytic track, and the hope is that based on the success that we have, we will continue or apply for more funding from NSF and other agencies. This is our project team. So what you see on the top are the people who are actually contributing and working really hard. Sain is a postdoc with me. Changyan is a PhD student. Rensi is a master student. Yusuf is a postdoc at University of Iowa. And then at the bottom, you see us, the collaborators. So Amanda Cox from St. Louis University, Ibrahim Demir from University of Iowa. This is me. This is Toby Miner from University of Colorado, and Marian Maste from University of Iowa. So this is our vision, and what I plan to do is I plan to give you a flavor of some of these things, and then after my presentation, Ibrahim and Yusuf will talk in more detail about cyber infrastructure, and then I'll come back and talk about tools that will relate to research and education. Since this is a community effort, so we wanted to engage with the community. So we had our first workshop last year, and the goal of this workshop was to basically understand what is available within the community and what we can do for the community. And also we wanted to identify key partners with whom we can work and work with their data. So after that workshop, we identified 3 partners, 3DEP from USGS, GDEP, again USGS, and Army Corps of Engineers, and eHydro. And what you see here are the individuals and the organizations that participate. So we had 49 individuals representing 23 government or agencies. And if you want to learn more about what was presented, you can find that on our workshop link that you see here on the right. And the PowerPoint that you see here will be available after the workshop on our website, which is rimorphis.org, that you see here on the screen. This is where we are today. So we are having our second workshop. We had a large number of registrations. So we had 150, and with this virtual, what we have learned is if you get half of them, you can think of that as a success. And I see on my screen, we have 73 participants, which is a good number, and we are happy for your interest and participation in this workshop. So of the registrations, we had 50 international registrants, and then we have a lot of participants from most federal agencies: USGS, NOAA, USDA, US Forest Service, Army Corps, and DOE. And then we had 23 universities represented in the registration list. And we also have people from NSF, JPL, Quasi, and also some industry participants. So again, I want to take this opportunity to thank all of you in participating today and showing interest in what we are doing. And I hope we will continue working with some of you and grow this community. I'll briefly talk about the infrastructure part, and in detail, you will hear about this from Ibrahim and Yusuf. So we want to create a framework that is connected the way you see here. So what you see here is cross-section. That cross-section is connected to reach, and that reach is connected to a network, and network is part of the watershed. So whatever we are doing, we want to make sure that it fits into the framework. So if you're looking for a data, you should be able to go to a watershed, find the reach, and if you are interested in cross-section information or any data related to that cross-section, you should be able to find that. So the way we want to do this is connect everything using a stream network as our backbone, and we are using NHD plus high resolution as our skeleton to do all the connections. And to support that conceptual framework, we have a cyber infrastructure, and what you see here is the architecture for our cyber infrastructure. So we have a front end, and again, Yusuf will talk in more about this. So we have front end, we have back end that has all the data and the web service, and then we are supporting visualization and mapping, which you will again get to see when Yusuf presents his talk. And finally, we are going to have tools and computational analysis things that will be supported by the integrated modeling layer. So we have the map, we have the database, we have tools to visualize and do analysis. And again, this is just another view of what you are going to see, and you will hear more about this from Yusuf. So what you see here are the connectivity that I mentioned. We have catchments, then you have the stream network, and then there is a reach, and then there is a data model behind all this. And again, here is just a small snapshot of how that data model looks like. And then we are also building API. So for example, if you want to interact with RIMORPHIS remotely, you can use API that we are developing to use some of the tools or to access data and to do things that RIMORPHIS will be doing remotely by using API. So the second part now I'm going to talk about is how we are going to work with our partners to enable what we promised. So what you see on this slide is our conceptual thinking of how we want to do this. And I'm going to use 3-dep as an example here. So we have 3-dep topography, and that data is a bathymetry data set in this case that you see here on the top left. It's an Excel file that has XYZ information. So when you look for 3-dep topography, most likely you will first find this article here, which is in Science Base, that will give you a link to their inventory, which is an ArcGIS map package. And then that map package has link to this article, which has the link to this data set. So it's not easy to find this, and eventually what you get is an Excel file which you have to bring into ArcMap and plot it, and what you get are these points that you see on the top right. So our goal is to make this process streamlined. So instead of going to that website, downloading the package, downloading the Excel file, and then trying to figure out how to map it in ArcMap, we want to create a system where you can go to an area, look for a reach, and if there is a data available, you should be able to click and get that data and make it available in a form that you want to use. So by using this conceptual framework, we started working with 3-dep and eHydro data set. And once you have those data sets, then the question is, how do I get them in a form that I want? And what you see here is if the data is collected as points, and if you want that data as lines, in this case, cross sections or mesh, we are going to have tools that will do that conversion. So with this conceptual thinking, we started working with eHydro dataset. And what I'm going to show you on this slide is how would you get eHydro data and what do you get after you are able to figure out how to access that data set. So this is a web interface for getting eHydro data. So you go to a map, and on the left, you see there is a download data link. After you download, this is what you get: bunch of files, and you have to find out where the data exists. And once you find out where the data is available, in this case, it's available in ArcGIS geodatabase format. And if you are able to find that and get it into ArcMap, this is what you see. So what you have here is a set of points. And again, as I said, if you are interested in doing hydraulic modeling, this set of points is not really useful to you. So the question is, how do you convert that point? So this is a manual workflow of how you will get to eHydro data. And what we have tried to do is we have tried to automate this process. And what you see on the slide is the RIMORPHIS interface of accessing eHydro. So what I'm going to do now is I'm going to hand this over to Yusuf, so who will talk about, so Yusuf and Ibrahim, they are going to talk about the cyber infrastructure behind our project and how they are making this happen. So instead of going manually downloading data, how you can click at a point and get to a place where you can easily access and use this data set. So I'm going to hand over it to the Iowa team now to talk more about the cyber infrastructure. And once they are done, we will come back and talk about the tools that we are developing. Before we do that, I would like us to take a picture or a screenshot of all of us, if you don't mind.